All right, so we left off on Thursday. We were started a little review, right? And you correct me if I'm wrong, but we did this problem, right? We evaluate, if I remember right, we evaluated this piecewise function, and I think we evaluated that piecewise function, correct? Give me a yes or a no in chat. Oh, is that true? We didn't do that? Okay. Never mind then. I thought we did. Okay, so let's talk about this. How do we review, or how do we evaluate a piecewise function here, right? So we have a piecewise function, remember, and you have one when you get this weird looking function like this where you have f of x equals, and then you have this open script bracket, and then you have rows, right? We have distinct rows. In this case, we have two rows. Each row corresponds to a piece of our piecewise function, and in this case, we have two pieces. Okay, so then how do we go about evaluating this? I want to check something. Are you guys sure we didn't? Man, I thought for sure we did that. No, we didn't. How about that? Okay, all right. Okay, so then how do we do this? Let's color code this thing. Let's take this top. Actually, let's do it this way. Let's make this our color code this. So we're gonna evaluate that one. We'll write everything in red. If I want to plug -1 into my function, when you have a piecewise function, you have to determine, okay, well, which piece am I plugging it into? Remember, when we have a piecewise function, we have two rows in this case. Each row always has two parts to it. It has the equation part, and then it has the domain part, which is telling us the values of the input that we can use for that equation, right? So, each of these pieces has its own set of input values, its own separate domain. So type in chat for me, give me a T or a B for top or bottom. Are we going to plug this -1 into the top piece or the bottom piece in this case? Just type your answer in chat. T or B is all you need to do. Okay, good. You're right. It goes in the top, doesn't it? Because -1 is less than 0. And so for part A here, we would get f of -1 equals, every place I've got an x in the top equation, I'm going to plug a -1 in for my x. So I get -5 plus 4 equals -1. Okay, so there's the answer to part A. What about part B? Let's do this one in blue. Where do I plug the 0 in? Top or bottom? Type it in chat for me. Okay, good. It goes in the bottom, doesn't it? Because 0 is not less than 0. 0 is greater than or equal to 0, isn't it? So we type it in the bottom, or plug it into the bottom. So every place I have an x, I'm going to plug in a 0. Well, 0 plus 5 is 5. And we're done. And then finally this, we won't even go, well, I guess we can. It's so quick. Top or bottom for that one, for part C? Where does the 1 get plugged in? Top or bottom? Okay, good. Goes in bottom because 1 is greater than or equal to 0. So f of 1 would be 1 plus 5 equals 6, right? That would be our answer for that one. It'd be 6. Okay. All right. Same kind of thing here. Let's look at, we'll just do 2 of these. How about, let's just do B and C. Okay, so what about this? Now look at this piecewise function. There's two rows, so there are two pieces. The top piece is the one that we have whenever x is not equal to 4, right? So if x is anything not equal to 4, then we plug into the top. When x is equal to 4, we plug into the bottom. Okay, so then for part B, am I plugging into the top or the bottom? Let me know real quick. Yeah, it goes into the top, doesn't it? Goes into the top because 0 is not equal to 4, right? That's true. 0 is not equal to 4. So we plug it into the top, and what do we get then? We get h of 0 equals, every place I have an x, I'm plugging in a 0. So I get 0 squared minus 16 over 0 minus 4. Well, that's just giving me 0 minus 16 is negative 16 over 0 minus 4 is negative 4. Negative 16 divided by negative 4 is positive 4, right? Okay, how about part C? Top or bottom? Good, it's bottom. Okay, good. So I plug it into the bottom, and every place I have an x, which is nowhere, I would plug it in. I don't plug anything in. H of 4 is just equal to 5, isn't it? The output of the bottom is just 5. So that's my answer. H of 4 equals 5. Okay, what about graphing piecewise functions? So now we've got to graph this thing. We've got to graph this piecewise function here. Okay, so we have to pick the correct one. I've got a piecewise function with two pieces here. So we'll have to just try these one at a time, I guess, and just see. We'll see if that top left one works. How about? So let's make this top piece, let's make that red. How about? So that's telling me that f of x is equal to the line 2x plus 5 whenever x is less than or equal to 0. It's equal to the line, we'll make this one blue, it's equal to the line 1/5 x plus 3 whenever x is greater than 0. Well, first of all, what's the boundary between the two pieces? What's the x value where we're transitioning between the red and the blue pieces? Type that in chat for me. What's the x value where the ant would jump from red to blue or vice versa? Okay, it's 0, isn't it? Good. So we know that x equals 0 is going to be the place where he's going to make that transition for values of x less than or equal to 0. So that's to the left, right? Over on the left, we're going to have the equation y equals 2x plus 5. So here's my vertical boundary line, right? There's my boundary line between the two pieces. There's the line x equals 0. To the left, for values of x less than or equal to 0, we're graphing y equals 2x plus 5. So that's just a line. Can you guys type for me real quick? What are the values of m and b, the slope and the y-intercept? Type that in chat. What are the values of m and b for that line? The red line. Got the line y equals 2x plus 5. Okay, good. M is 2, so the slope is 2 and the y-intercept is 5. Okay, so then we should have the point when this line crosses the y-axis, it should be at the point 0, 5. And it is, isn't it? Because look, we're going by 2's here. 2, 4, 6, 8, 10. So that is the point 0, 5. Okay, is the slope 2? Well, let's check. If I take two different points, like there's a point right there, and then there's a point up there, right? So let's calculate our slope triangle. Between those points, I would rise by 1, 2, 3, 4, and run by 2. Well, 4 over 2, yeah, that gives me a slope of 2, doesn't it? Right? So I can see that, yes, the slope is 2. So the red line matches up. How about the line on the other side? You might see a problem. We'll get to that in a second. How about the line on the other side? When x is greater than 0, so to the right of my boundary line, I've got the line y equals 1/5 x plus 3. Okay, so then that means we've got, for this one, we've got a slope of 1/5 and a y-intercept of 3. Okay, well, let's see if that works. So my y-intercept, sure enough, look, the coordinates of that point are 0, 3. So that one checks out. How about the slope of 1/5? If I go up 1 and I go to the right to get to that point, I go to the right by 5, don't I? So sure enough, my slope is 1/5. I've got the right slope. So is that the right one then? Is that the right graph? Yes or no? Alara's shaking her head no. She's right. What's wrong with that one, Alara? Yeah, the endpoints aren't right, are they? Look at our endpoints. For the red piece is the one that is including the equal sign. So the red endpoint needs to be closed, doesn't it? Right? Because we are including that equal sign, this one is supposed to be, how am I going to do that? This one is supposed to be closed. And this other one does not include an equal sign. So that one is supposed to be open. Okay, so it's the right, the lines are correct in every case, in every way, except that the endpoints are wrong. So then what's the correct graph? Well, the correct graph looks like it's this one down here, doesn't it? It's got the same lines, but the correct endpoints. Okay, everybody see that? Give me 1 to 5 on that, everybody. Okay, oh, good stuff. All right, so we know that one's not it. That one's not it. That one's not it. But this guy is. Okay, for our notes. There we go. Okay. Okay, how about this one? Real quick, which of those parent graphs, and I'm just going to go through sample questions on the test here. Remember, test is Wednesday. Which of those is the absolute value of x? Type your answer in chat. Which, it says, wants to know which one of the graph of f of it, which one is the graph of f of x equals the absolute value of x? So you have to be able to just recognize parent graphs on this one. Got it. It's F, isn't it? Whoops. There we go. Right, that's the one we want right there. V shape, over 1, up 1, over 2, up 2 on the right side. And it's got axis of symmetry through the vertex, right? Okay, how about this one? Which one is the graph of f of x equals x squared? Type that one in. There you go. It's k, isn't it? Good. And we recognize that's k because, look, it's the vertex is at 0, 0. It's a parabola. We go over 1 and up 1 squared, so over 1, up 1, over 2, up 2 squared, so over 2 and up 4, right? And we have folding symmetry about the axis, vertical line through the vertex, right? So that's good. Okay, what about these now? Let's match these things up. The top one, what letter does, so we're looking at this guy right here, right? This top one. Type in the letter that we matched that with. Lowercase a matches up with which type of transformation? A, B, C, or D? Okay. Good. Yeah, we're going to the right, aren't we? Right? We're going to the right by 5 if I inside the function if I subtract 5 from x. So those two, whoops. Those two match up, huh? Okay. How about the next one? X squared minus 5. Which one does that go with? Type your answer in chat. I'm subtracting 5 outside the function. So what am I doing? Good. C. I'm going down by 5, aren't I? Okay, next one. Y equals 5x squared. I'm multiplying the function by 5. Okay, good. So we're going vertical stretch by a factor of 5. What if I do y equals the quantity x plus 5 squared? Which one does that go with? Okay, good. That's going left by 5, and then that only leaves 1, doesn't it? So if I add 5 outside the function, I'm going up. Good. Okay. How about this one? So we won't have to do all these things, but let's just skip down and let's try. How about, let's try G first. Okay, so there's the function down at the bottom. Type in chat, which one of those graphs matches up with the quantity x minus 3 squared plus 1? Now on the test, you could make those bigger if you wanted to, right? Okay, good. Looks like H, doesn't it? Yeah, looks like H. How come? Because the values of H and K are 3 and 1, and those are the coordinates of the vertex. In other words, we've shifted right by 3 and up by 1. Okay, perfect. So we know this guy was, that was an H, wasn't it? Okay. How about, let's do F. So we're looking for y equals negative x squared. Negative x squared. Which one is negative x squared here? Negative x squared. Type in the answer for me. Okay, good. It's D, isn't it? It's right here. because our vertical dilation factor is -1. So instead of going over 1 and up 1, we're going to go over 1 and up 1 times -1. So we're going down 1. Perfect. Okay, so this guy was a D. How about we'll look at E. Which one is 3x squared? So y equals 3x squared is what we're looking for. Which one would that be? Kind of hard to see those, but if you think about it, only one of those could be right. Which one is 3x squared? Y equals 3x squared. So I'm multiplying the function. There we go. Multiplying the function by 3. What does that do? Okay, I'm getting some B's and F's on this one. Which one is it? Is it B? Did the function get translated up by 3, or is it F? Did it get stretched by a factor of 3? And once again, the function that we're dealing with here is, so we're looking between these two, right? The function is y equals 3x squared. So that's a value of A, right? So what do you think? Okay, now it looks like we're getting more F's. Yeah, F is correct, right? Because we're stretching. When we multiply the function by 3, we're stretching it by a factor of 3. So on this one, H and K are 0. So the vertex is at the origin. But instead of going over 1 and up 1, we're going over 1 and up 3 times 1. So over 1 and up 3. Yeah, that's correct. See, I get a point there, and I get a point there. So that's the right one. Okay, and I'll open all these up for you. So on the notes, if you want to check yourself on the rest of these, you can too. Okay, moving on. How about one like that? Which one of those is right? So now, this is an absolute value function. It's in vertex form, isn't it? Right? It's in vertex form. So it's in the form a times the absolute value of x minus h plus k, where h and k represent the coordinates of the vertex. So you type in for me really quick in chat, what are the values of a, h, and k for f of x? Okay, let me get more answers. Good, I should get answers from everybody. Okay, those are looking mostly good, but the one you gotta be careful about is h, right? So we get a is equal to 7. H is equal to -3, isn't it? Right? Because we're subtracting a negative to make a positive. Remember, it's always the opposite of whatever the operation is that connects h to x. So h is -3 and k is 0. Okay, so then we know the vertex has to have coordinates -3, 0. So we can cross off that guy, we can cross off that guy. Well, which one is it here? If a is equal to 7, we must have stretched it vertically, so doesn't it have to be then this one right here? Everybody agree? It's got to be A. We go over 1. Instead of going up 1, we go over 1 and up 7. Okay, good. All right, now I'm just going to pull up the test, I think, and we'll just go through some sample problems. How about, let's see, skip that. Okay, let's try this one. Okay, what form is that in? Is that in vertex form or in standard form, first of all, h of x? Vertex or standard? Just give me a V or an S. Okay, good. Yeah, it's vertex form, isn't it? Very good. So then I need to know what, if it's in vertex form, I need to know the values of A, H, and K, right? Because we know, so type those in chat, please. We know that in vertex form, vertex form is A times the quantity x minus h squared plus k for a quadratic function, right? So what are the values then of A, H, and K for us? Type those in. Okay, I need more answers, everybody. Okay, good. So A would be, there's our -2, good. H is 4, because that's what we're subtracting from x, +4. And K is 3, good. So then we know that our vertex has coordinates 4, 3. So there's our vertex. Everybody type the axis of symmetry in there for me, please. Type in the equation of the axis of symmetry. Good, there we go. So x equals h, which in this case is 4. Good. So if I want to graph this thing, then I know where the vertex is. Okay, here's the next thing I want to know. So I'm graphing a parabola, right? When I graph this parabola, I'm going to have a point over here with coordinates 4, 3 that is my vertex. Here's my question. If I go over 1, what do I do vertically? So in other words, I want you to fill in, here's my question for you. I'll type it in chat. Over 1, what? To get to the next point from the vertex. If A is -2, normally on my parent function, I would go over 1 and up 1, right? Over 2 and up 4. What am I doing this time? Over 1 and what? If A is -2, what's that mean? Let me hear from everybody. Good. Yeah, I'm going over 1 and up 1 times -2. Over 1 and up -2 means down 2, doesn't it? Good. So over 1, down 2. So we should be able to pick this one out then, right? So let's go to this problem on the test. Oh, and notice they want us to do 2 things here. You got to read these questions carefully. It says use the graphing tool to graph the function as a solid curve and the axis of symmetry as a dashed line. Okay, so you guys already told me the vertex was at 4, 3. Axis of symmetry was x equals 4. Now we just have to graph it. So over 4, up 3. There's, oops, I got to grab the parabola tool. Over 4 and up 3. Okay, and look, I can see that when I point at that, I've got the right coordinates. And then you told me over 1, down 2. Okay, so there's the parabola, but remember it wants me to graph the axis of symmetry as a dashed line. So now I've got to go over and grab the line tool, and I'm going to make a dashed line, and I just have to make a vertical line through the vertex, right? That look good? Okay, let's try it. Hey, we got it. What do you know? Okay, here, I'll take a picture. Oh, darn it. Okay, so on the notes, I got a picture there for you. Let's try another one. Okay, what about one like this? Okay, so what form is this quadratic function in? Vertex or standard? Give me a V or an S, please. Okay, good. That's standard form. Good. Real quick, everybody type out what is standard form. So y equals ax squared. Okay, type that out for me real quick. So ax squared plus bx plus c, right? So what are the values of a, b, and c for this function? Okay, 1 is the coefficient of x squared, -4 is the coefficient of x, and 1 is the constant, right? So 1, -4, 1. Good. Type in the formula. We have to find the vertex. So type in the formula for calculating h, please. What's our formula for calculating H? Good. Negative B over 2A. Very good. Okay. And so let's see. If B is -4, negative B is +4. Divided by 2 times 1 is 2. So everybody agree we get H equals 2. What's the formula for calculating K? What's the formula for calculating K? Okay, good. To find the y coordinate, I just plug x into the function, right? So K equals f of h, which in this case is 2. So what's that give me? If I plug that into my function, I'm going to get 2 squared minus 4 times 2 plus 1 if I'm plugging 2 in for my x's. So K equals 4 minus 8 plus 1, that's all -3. Okay, so I know the values of H and K are 2 and -3, so that's the vertex, right? And I know A is equal to 1. So let's graph that then. So vertex we said was, what was it, 2, -3, wasn't that it? Give me a thumbs up. Was that right, Melinda? 2, -3, okay. Okay, and then we need to graph this thing, right? So they just want the parabola this time. So vertex at 2, -3, and fill in the blank for me in chat, please. Over 1 what? If A is equal to 1, over 1 what? To get another point. Okay, good. I'm not doing, A is 1, so I'm not stretching or compressing or anything, right? So over 1, up 1, just a regular parabola. That's what it looks like. There it is. How about that? Okay, so let's add that to our notes. How about? Okay, there it is. Let's maybe do one more here. Okay. Okay, let's try this one. By the way, on the test, just so you know, the last problem on the test is kind of a bonus. It's only worth 1 point. So it's not really going to change your score too much, but to get 100%, you'd have to get it right. Okay, so let's try this guy. we know that's in standard form. We're supposed to write it in vertex form and graph it, okay? This is really just the same problem we did last time, isn't it? If I know the values of A, H, and K, I can just plug those into my vertex form template to write it in vertex form. So this is starting off in standard form, right? And we're trying to convert it to vertex form. What are the values of A, B, and C, please, for this one? Okay, good. So 7 is A, B is negative 28, C is 14. You already told me the formula for calculating H. Negative B over 2A. So let's plug that stuff in then. B is negative 28, so negative B is positive 28 divided by 2 times A. Well, A is 7. 2 times 7 is 14, right? 28 over 14 is 2. So we know H. Now let's calculate K, but let's go ahead and use Desmos just to remind ourselves how we can use Desmos for this. Because in this case, we'll get a little bit bigger numbers. Not that it's such a huge deal, but if we use Desmos for this one, remember how this works, right? All you have to do is we have to write the function in function notation. So instead of y, we're going to call it f of x equals, and there it is, 7x squared minus 28x plus 14. Okay, and then we just have to go down and evaluate the function, in this case at 2, right? F of 2, and it gives us negative 14. Oh man, am I using the right? Let me check something. Tell me I am. I think I am. Okay. All right, so we know K then equals negative 14. And we know A is 7. Okay, so then please write this in vertex form then. What's going to go there? If I want to write this function in vertex form, we know A is 7, H is 2, K is negative 14. So everybody write that function out in vertex form, please. Okay, let me hear from everybody. Okay, good. Good. So I'm just plugging in values then, aren't I? I'm plugging in the values 7. H is 2. And K is negative 14. So I just get Y equals 7 times the quantity X minus 2 squared minus 14. Okay, let's graph this one and we're done. Oops. Okay, so there's what we did. And to graph this, we've got a vertex at 2, negative 14. Oops. Now notice you can see the coordinates that I'm pointing at up there, so you can just double check yourself. So there it is, 2, negative 14. Now answer the question for me this time. Over 1, what? A is 7. Okay, good. Over 1, up 7. There it is. We got it. How about that? Picture for the notes. And you guys are good to go. If you can do that stuff, you're going to do great on the test. There's not much to it. All right. I'm going to let you go a minute early. Get up and stretch. Get a quick snack, drink of water or something before advisory. Have a great day. I'm here after school if you have any questions. Otherwise, I'll see you on Wednesday. Remember, test Wednesday.
Master Oya?
Yes.
Some of the late crew leaders aren't going to be here in the morning they won't be in this class on Wednesday.
Oh, you're fine, McKenna. No big deal.
Okay.
Yeah.
Should we just come in for
Yeah, or you can do it Friday.
Okay.
Yeah, Friday's fine. Yep, that works.